A thread on our Ask Mechanics exploded recently. A user posted a single question. The user said they were a master technician with 18 years of experience. They said they would never in their life buy an electric vehicle, and they asked, "Am I wrong?" The replies flooded in from professional mechanics across the country. Not from people who are afraid of new technology, from people who see inside these vehicles every single day. From people who know what happens after the commercials stop running and the real world starts breaking things. And what they are seeing has turned an entire profession against electric vehicles. Today, we are exposing the battery brick trap. We are going to show you the specific failure modes, the specific cost structures, and the specific manufacturer decisions that are turning electric vehicles into the most expensive mistake in the history of consumer transportation. We are going to show you what the dealerships are not telling you when they hand you the keys to your $55,000 battery on wheels. And we are going to show you exactly what smart buyers are doing instead. Here is the number that rewrites the entire EV conversation. The average replacement cost for an electric vehicle battery pack in 2025 is between $12,000 and $22,000 depending on the vehicle. Not a minor repair, not a component swap you can do in the driveway. That is a bill of $12,000 to $22,000. It typically arrives between 100,000 and 150,000 miles. And that happens on a vehicle that originally cost you $45,000 to $80,000. When that battery fails, the trade-in value of your electric vehicle drops to approximately the value of the steel in the frame. Dealers do not want them. Private buyers do not want them. Auction houses run them through at a loss. The moment that battery pack crosses a certain degradation threshold, your $55,000 Chevy Bolt becomes a $3,000 paperweight. That is the battery brick trap. And every single person selling you an electric vehicle right now is hoping you do not do this math before you sign. Let us start with the Chevrolet Bolt, because the Bolt is the canary in the coal mine for every electric vehicle on the market today. The Bolt launched in 2017 with a 60 kilowatt-hour LG Chem battery pack. General Motors marketed it as a revolutionary leap in affordable electric transportation. By 2020, the National Highway Traffic Safety Administration had received hundreds of fire reports. Not overheating, not degradation. Bolt battery packs catching fire while parked in garages. General Motors issued a stop sale order, then a stop charge instruction, then a recall covering approximately 140,000 vehicles at a cost to General Motors of over $1.8 billion. LG Chem eventually agreed to reimburse General Motors $1.9 billion. The affected owners were made whole on that specific recall. But here is what they lost that no check could replace. They lost the fundamental promise of the technology. They were told lithium-ion battery packs were stable, safe, and durable. The real world answered that promise with a garage fire. And that was a brand new battery on a brand new vehicle. Now imagine what happens to that chemistry at 120,000 miles. A forum user named EV Mechanic No More posted a breakdown that circulated through every major automotive community online. He wrote, "I work at a Tesla certified service center. In the last 90 days, I have seen 4 Model 3 battery packs fail completely, between 90,000 and 130,000 miles. Tesla's out-of-warranty replacement cost runs from $13,000 to $20,000 installed. Every single one of those owners bought the car thinking they were saving money on fuel. None of them were saving anything." Let us talk about why battery degradation is not a glitch. It is physics. A lithium-ion cell works by moving lithium ions back and forth between a graphite anode and a lithium oxide cathode through a liquid electrolyte. Every single charge cycle causes microscopic structural damage to both electrodes. The graphite anode develops a layer called solid electrolyte interface. It grows with every charge. It permanently traps lithium ions. It reduces the capacity of the cell incrementally, but inevitably. There is no maintenance procedure that reverses this process. There is no fluid you can change. There is no seal you can replace. The degradation is written into the chemistry of the cell itself. Engineers at every major battery manufacturer know this. The battery is not designed to last the life of the vehicle. It is designed to last the duration of the warranty. On most electric vehicles, that warranty is 8 years or 100,000 miles. The mean time to significant capacity loss on the most common electric vehicle battery packs clusters right around that window. Not comfortably before it, right after it. You might think this is an engineering problem they are actively solving. Think again. Solid-state batteries have been 18 months away from mass production for the last 12 years. The lithium-ion chemistry in every electric vehicle on the market today is fundamentally the same chemistry that was in the first-generation Nissan Leaf in 2011. The packaging got better. The thermal management got more sophisticated. The underlying degradation curve did not change. And now, let us talk about the repair wall that no electric vehicle salesperson will ever mention. On a gasoline vehicle, a failed component is a contained problem. Your alternator dies. You replace the alternator. Your water pump fails. You replace the water pump. The rest of the vehicle is completely unaffected. On an electric vehicle, the battery pack is not a component. It is the vehicle. On the Tesla Model Y built at the Texas Gigafactory after 2022, the structural battery pack forms the actual floor of the car. It is not bolted underneath with a set of standard fasteners. It is integrated into the vehicle's load-bearing structure with over 50 fasteners of multiple types and sections bonded with structural adhesive. To remove it requires a specialized lift, a proprietary battery support cradle, and a factory-trained technician with access to Tesla's closed diagnostic ecosystem. An independent shop physically cannot perform this repair. They do not have the software required to authorize, configure, and activate the replacement pack. Tesla controls the entire repair chain from the factory floor to the service bay. You do not just buy a battery, you buy permission to have Tesla install it. At Tesla's price. On Tesla's timeline. Whether you like it or not. A mechanic named Wrench and Volt TX put it plainly on a professional forum. I have been fixing cars for 22 years. I cannot work on a Tesla. Not because I do not understand high voltage systems. Because they will not sell me the parts and their diagnostic software refuses to talk to any third-party tool. The customer is 100% at Tesla's mercy. And Tesla knows it. The insurance industry has already run the numbers that the manufacturers are hoping you never see. When an electric vehicle is in even a moderate collision and the battery enclosure sustains structural damage, most major insurance companies total the vehicle immediately. Not because the car cannot drive, because the cost of a battery inspection, the liability of certifying a repaired high-voltage pack, and the replacement cost if the pack is condemned exceeds the vehicle's actual cash value. A 2022 Tesla Model 3 with 60,000 miles was recently written off as a total loss after a low-speed parking lot impact caused cosmetic damage to the underside battery enclosure. The car drove away under its own power. It was functionally identical to the moment before impact. The insurer totaled it because the battery safety inspection alone was quoted at over $4,000 before a single repair dollar was authorized. Now add what is happening in 2025 to an already broken equation. Federal tariffs on lithium-ion battery cells, battery management components, and thermal management hardware imported from China have pushed wholesale battery pack costs higher before they even reach the service bay. Industry analysts are projecting that the average out-of-warranty EV battery replacement cost will cross $25,000 on mid-size platforms by late 2026. The result is soaring replacement costs that hit owners long after warranties expire. The battery brick trap is not staying the same size. It is getting larger every quarter, and it is landing on vehicles that are sitting in driveways right now. The dirty secret the EV industry refuses to discuss publicly is the used EV market collapse. A 2019 Tesla Model 3 long range that sold for $49,000 new is now clearing auction at $14,000 to $18,000. That is not simple depreciation. That is battery anxiety systematically destroying residual value across every brand and every platform. Every buyer in the secondary market knows they are one degradation report away from a $15,000 to $20,000 repair bill on a vehicle worth $16,000. So they do not buy. Or they pay almost nothing. and the original owner who bought the EV to save money on gas absorbs a $30,000 depreciation hit on top of insurance premium increases that arrived after the manufacturer sold driving data to LexisNexis and Verisk. Forum user depreciation trap _EV posted the math last week on a personal finance board that was shared across 4 major automotive groups. He wrote, "I bought a 2020 Model 3 to save $150 a month on gas. I am selling it for $22,000 less than I paid. I would have needed to drive it for 12 years at zero fuel cost just to break even on the depreciation alone. The math was never there. I just did not look." He looked too late. You do not have to. So what are smart mechanics doing right now? They are not buying electric vehicles. Full stop. They are buying the last generation of proven gasoline vehicles, with documented long-term reliability records that stretch back 20 years of real-world data. Trucks and engines with failure modes that are known, cheap, and fixable in a driveway with hand tools. For drivers who genuinely want better fuel economy, smart mechanics recommend full hybrid platforms only, not plug-in hybrids with their dual system complexity. Full hybrids like the Toyota Camry hybrid with the A25A FXS engine, or the Toyota RAV4 hybrid with the M20A FXS. These run a small nickel metal hydride battery pack with a documented real-world service life exceeding 200,000 miles, on a chemistry that does not suffer the same structural degradation as lithium-ion. The original battery pack in a 2007 Toyota Prius is still functioning in hundreds of thousands of vehicles today. That is 18 years of uninterrupted real-world proof. No electric vehicle manufacturer on Earth can show you that data, because their technology has not existed long enough to generate it. The electric vehicle industry is not selling you transportation. It is selling you a financial instrument with a hidden liability clause buried in the battery chemistry. They want you focused on the charging cost per mile. They need you to ignore the $15,000 to $20,000 bill waiting under the floor for the day the warranty expires and the lithium ions stop moving. Have you owned an electric vehicle and been hit with unexpected battery degradation or repair costs? What was the make, the model year, and what did it cost you? Sound off in the comments below. Your experience is the data manufacturers are spending millions to keep out of the conversation. If you refuse to drive a $55,000 vehicle with a $20,000 liability hiding under the floor, hit the subscribe button and join the resistance. Keep the old iron running. Keep turning your own wrenches, and we will see you in the next one.